Marty here. In our last set of notes, we talked about relations. And we saw a table like this, but it said relation up here. And now we're going to talk about functions. Functions are a type of relation. Okay? And to specifically define it, a function is a relation. Okay, so we've already talked about that. It is a relation. Function is a relation where every input, that's x, every input x has exactly, and I'm going to make this big letters and I'm going to underline it, exactly one output or y. Okay? Every input, or x, has exactly one output, y. Okay? So what that means is the x can't repeat. You never have more than one x that has the same value. Never have more than one x that has the same value. Okay? Well, what are some examples of functions? We're going to skip down here. Well, what if I had a set that looked like this? 1, 2, -3, 4, 7, 5, and 8, 2. Now, we have a 1, a -3, a 7, and an 8. Does the x ever repeat? No. So that means it's a function. Okay? Other examples, we could have a table, right? Remember our input-output table? We could have 3, 2, 5, 7, 1, 4. We have a unique individual x for each one here. That means this is a function. We could also have a graph. Okay? Great example. We're going to be talking a lot in our next unit about lines. Actually, it's exclusively about lines. A line like this would be a function. That would be a function. Okay? Why is that a function? Well, for every x value, right, our x-axis is here, our y-axis here. For every x, as you moved left and right here horizontally, there's a new y value. We never have a situation here where for one given x, there's a point here and a point here, or a point here and a point here. We're going to see as non-examples that that's an important property of functions. Okay? So what are some non-examples? Well, what if we had a set that looked like this? 5, 3, 7, 4, 5, -1. Uh-oh. We've got a 5 here and a 5 here. The x is repeated. And remember, our definition of a function is there's exactly one output for each input. So that means here, because there's two outputs for 5 could be either 3 or -1, not a function, right? What might that look like in terms of a graph? Well, we're going to learn something called the vertical line test. If I had a graph that looked like this, okay? Right here, or actually any point, there are two y values for one x, okay? That's not a function. Not a function. Another example, a vertical line. Look at a vertical line. There's more than one y value for each x, right? For this x, there's 1, 2, 3, 4, 5. There's actually infinite y values. So that's not a function, okay? So functions are a relation where there's exactly one output for every input. The x does not repeat. Well, let's move on to the next page in our notes, where we're talking about am I a function, and let's see what we mean by that, okay? So this says, am I a function? There's a couple different ways we can determine whether or not a set of data points is a function or not. The first is to check for duplicate x-coordinates when given a set of coordinates. So here we're given a set, right? This is a set, data points. So let's go through the x's and see if there are any repeats. Here we've got a 3, 8, -3, -2, 2. No repeats at all, right? So what is this going to be? This is going to be a function, right? Yes, function. How do we know? There are no x repeats. But our second one, 5, -4, 6, 5, 4. We've got a 5 here. We've got a 5 here. So this is no, not a function. Why? Because there is an x repeat, right? The 5. That's one way. Now, so if you're giving a set of coordinates, you can just look at the domain. The domain is the x values, see if there are any that repeat. Second way is something called the vertical line test. On any graph, if you're given a graph, you can draw a vertical line. A vertical line is one that's straight up and down. If there's any point on a graph where you can draw a vertical line and it crosses the graph more than once, then it's going to be not a function. Well, why? Because every x value has to have only one y. So if we look at this graph, this is a parabola, right? If I draw a vertical line, I'm just going to show you some examples. I could draw one here, I could draw one here, right? The graph only crosses it once. So because I can't draw a vertical line that crosses the graph more than once, this is a function. It passes the vertical line test, right? Vertical line test says if you can draw a line, vertical line, straight up and down through a graph and it crosses the graph more than once, so it intersects with the graph more than once, it's not a function. This one, look at this. If we draw a vertical line any of these places, it crosses twice. Guess what? No, not a function. It fails the vertical line test. Okay? Fails the vertical line test. Then finally, we can determine whether something's a function by looking at a mapping diagram. What are we looking for? We're looking to see if every x value has exactly one y value. Okay? Well, we had -1 to 2, 0 to 2, 1 to -3, 2 to -2, 8 to 3. If you notice, every one of these has only one line coming from it. Because there's only one y value that corresponds to each x, this is a function. Over here, however, it's looking good. 1 to 2, 2 to 3. The 3 and the 4 don't have anything, but 5 goes to both 4, 5, and 7. That means it's no, not a function, because there's more than one y for that x value of 5. There's more than one y. There's 4, 5, or 7 for that x value of 5. So how do you determine if something's a function? Well, remember, a function has one output for every given input. That means for each x, there's only one y. So we look and see if we have a set of numbers. Are there any repeats in x? If there are repeats, it's not a function. If there are no repeats, it is a function. We can draw a vertical line through a graph. If it intersects the graph more than once, like here, 1, 2, not a function. If it doesn't, only intersects once, it is a function. Finally, we can look at a mapping diagram. If there's only one line coming from each of the x values, it is a function. If there's more than one line coming from any x value, it's not a function. So that's a quick introduction to functions. Remember, they're a type of relation where there's exactly one y value for each x value. We'll be back next time to talk about function machines and function notation.